What's up, my people? Intro to derivatives. In this video, we're going to learn about the quotient rule. Oh yeah. This rule is going to make your life so much easier when you're finding derivatives of quotients. All right, so first off, when the heck do we use the quotient rule? If you have a function that can be viewed as two functions being divided, use the quotient rule. So here's two examples. We have 3x squared minus 2x. Divided by 5x plus 3. So two functions, it's one function, but you could view that as two functions being divided. And another example here is cosine of x divided by 4x squared. Again, you could view that as two functions being divided. Now, to explain this rule, we're going to label each of the two functions with a u and a v. So like we could say the numerator is u and the denominator is v. And that's how we're going to explain how to use the rule. So u is referencing the numerator, v is referencing the denominator. So here it is, the rule to find the derivative of u divided by v. So if you have a function with a function on top divided by another function, we could use the quotient rule. Get ready, this rule is awesome. Here it is. So to find the derivative f prime of x, we start off with v. Just leave it, take the denominator, leave it alone. Then you multiply by the derivative of u. So you do have to find the derivative of u, multiply that by v. Then you subtract u. So this time you leave u alone, leave it as original function, don't change it, and multiply that by the derivative of v. All divided by the denominator v squared. So there's no derivatives. The denominator has nothing to do with any derivatives. You just take the v, whatever it is, and you square it. So once again, you got to be very careful with this. Order does matter with subtraction. Product rule was addition, and addition doesn't matter. So even if you kind of mess up the order of the product rule, you could still get away with the correct final answer. But the quotient rule, order matters big time. If you do it out of the wrong order, you're going to get it wrong. So just remember, again, this is why you might want to have it like written down when you use it. But always start with the denominator. Start with the denominator v, leave it alone, just rewrite it, multiply by the derivative of u, then subtract, and you kind of flip that. Then you start with u, multiply by the derivative of v, all divided by v squared. This is going to save you so much time, so much effort. It's an awesome rule, the quotient rule. Now, another way, I want to give you another look at this, right? So we talked about, when you use the rule when you have a function divided by a function. So we were just labeling it u and v, but some people will label the numerator as f of x, the denominator as g of x. So instead of just labeling it u and v, some people label it f and g, which is fine, obviously, right? So again, here is a different look at the quotient rule, but it does follow the same rules. So again, notice this notation here. This is just, hey, the derivative, with respect to x. Don't let that confuse you or complicate things. It's just the derivative, right? So the derivative of a quotient is a function divided by another function but again, it's the same rule I just showed you, right? Start with the denominator, rewrite g of x, just leave it as it is. Multiply by the derivative of the top, that's the derivative of f. Then you're going to subtract and you're going to switch that around. You're going to take f, the numerator, leave it alone, multiplied by the derivative of the denominator, and then you're going to divide it all by g of x squared. So you're literally just going to take your denominator and square it. Nothing to do with the derivative in the denominator. And overall, that final fraction there will be your derivative. All right, let's go ahead and put it to use. I want you to see how easy it is. All right, now here is a problem that is definitely a quotient. We got a numerator, we got a denominator. But we actually already know how to do this problem. Because remember, I already taught you how to do this problem. The first thing I taught you was, first off, rewrite it as x to the negative 3, because we want to use the power rule, so we want to rewrite it. So with the 5/2 is just a constant, just kind of leave it there, and then the x is going to move to the top or again to the side as x to the negative 3. Then to find the derivative, we know the power rule says drop that negative 3 down in front, which makes negative 15/2, because when you drop that negative 3 down, it multiplies, times x to the negative 4. Power rule says subtract 1 from your exponent. So after I clean that up, because we don't want a negative answer, so I'm going to move that x to the positive 4 in the denominator. So there is your derivative. But I want to show you right now, and again, that is how I would recommend doing this problem. But I want to show you how the quotient rule could get you that same answer. But I'm still going to, I'm using this as an example to kind of walk you through using the quotient rule. But I would still encourage you to use the power rule to solve this problem. But some kids, after they learn the quotient rule, they see, anytime I see a fraction, I'm going to use the quotient rule. And really, that's fine. All right, so quotient rule says this. Start with the denominator. Leave it alone. 2x cubed, don't change it all. Multiply that by the derivative of the numerator. Well, the numerator is a 5. That's a constant, and the derivative of a constant is 0. Now, when I use the quotient rule, I always use parentheses just to kind of keep all the parts separate, and then I'll clean it up after that. So you'll see me do that a lot in this video. Minus, now this time I'm going to take the numerator, 5, and I'm going to multiply by the derivative of the denominator. The derivative of just the denominator, if I look at the denominator as its own thing, 2x cubed, it's 6x squared. Right? 3 falls down, 3 times 2 is 6, 3 minus 1 is 2. So again, I'm just treating it, right? I'm treating u is 5, v is 2x cubed. And the rule says, start with v, write it down. Times it by the derivative of u, the derivative of 5 is 0, minus u, just 5, multiplied by the derivative of v, 6x squared. All divided by the denominator squared. So I'm going to take 2x cubed, no derivative or anything, just 2x cubed, and square it. All right, now I got to clean it up. Well, this first part is easy because anything times 0 is just completely wiped out. It's all gone. So all I have is negative 30x squared. Negative 5 times 6 is negative 30x squared. All divided by, now on the bottom, I got to square this, right? So 2x cubed all squared becomes 2 squared, 4. X to the 6, right? When you have a power to a power, you multiply. But wait a minute, I can clean this up, right? Negative 30 over 4 reduces to negative 15 halves. X squared on top will reduce with the x to the 6 on the bottom. There's x on the top, x on top. So 2x's on top will cancel with 2x on the bottom, and I'm over with x to the 4th left in the bottom. And hey, what do you know? It's the same final answer I got over here. But listen, I would recommend using the quotient rule, I'd recommend using the power rule over the quotient rule. It got us the answer faster. But I did want to walk you through how the quotient rule can be used. The point I'm trying to make here is that the quotient rule is used for more advanced functions that we're going to see in a second. If you could easily turn it into a power, use the power rule, please. All right, so here is a problem where definitely cannot turn this into a power function, right? I clearly have a much more complicated function, 5x plus 3 in the denominator, 3x squared minus 2x in the numerator. I can't just easily like move something around and make it a power function. So I'm definitely going to have to use the quotient rule here. So easy. Remember, treat the top as u, the denominator is v. All right, so the derivative of this function. Now, this is going to take some time, but let's walk through it. Write the denominator alone, 5x plus 3, leave it alone, straight up v. Multiply that by the derivative of the numerator. Now again, you should be able to find the derivative of that numerator pretty quickly by now. It's going to be 6x minus 2, right? 2 falls down in front, 6x to the first, so 6x minus 2 is just minus 2, right? Again, I hope by now you know the power rule pretty well. There is a 1 right here. That 1 falls down. Negative 2 times 1 is negative 2. And then 1 minus 1 is 0, so my leftover power is 0, but x to the 0 is 1, so you don't even have to write it anymore. Okay, hopefully we know that by now. That should be easy. Minus, now this time I'm going to write u alone, 3x squared minus 2x. Just kind of leave it normal. Don't make any changes to it. I'm going to multiply by the derivative of v. The derivative of v is just 5. Hopefully that's very simple for you guys, right? Again, 1 falls down. 5 times 1 is 5. X to the 0. X to the 0 is 1, so don't even write it down. And then again, the derivative of 3 is a constant, just 0. So that's how we get 5. And then again, the denominator is now super easy. All you're going to do is take your v, 5x plus 3, squared. That's it. All right, so now we have actually found the derivative. That is, everything right there is the derivative, but now we got to play cleanup. So let's go ahead and multiply everything on the numerator out, and let's take our time with this. This is not a sprint, it's a walk. So let's see here. So I get 30x squared. Outside is negative 10x, inside's positive 18x, and then lastly we have a negative 6. Now over here I have to distribute the 5, but I also have a minus sign, so I'm going to distribute a negative 5. So I get negative 15x squared, positive 10x. So once again, I'm distributing the 5, 15x squared minus 10x, but then the negative comes through as well, so that's how I got negative 15x squared plus 10x. All divided by, now I'd actually recommend, a lot of kids I hope you're going to be okay with this. Don't do anything on the denominator, right? Just leave it as 5x plus 3 squared. You can square it out, but it's actually cleaner looking if you don't. All right, so all I have to do now is combine all my like terms in the numerator. So a 30x squared and minus 15x squared is 15x squared. A negative 10x, a positive 10x are going to cancel. That's awesome. But I do have an 18x still. And then minus 6. So that is all over 5x plus 3 squared. And I would actually leave my answer just like that. That's a great final answer for a derivative. Not too complicated at all. All right, next problem here. Now I got some trig involved in this, but I definitely have one function in the numerator, one function in the denominator. You can go ahead and call that u and v if you want to follow the formula. Very, very simple here to find the derivative. All right, I'm going to take v. Leave it alone, 4x squared. Multiply by the derivative of u. The derivative of cosine is negative sine. That's one of those ones you just got to memorize. Minus, now this time I'm going to take the numerator, u, cosine of x, leave it alone. Multiply by the derivative of the bottom, 8x, 2 falls down, 2 times 4 is 8, new power is 1. That's easy. All divided by, sorry for my messiness there, I'm just going to take 4x squared, squared. The denominator, squared. Now, unfortunately, this actually is a good problem. Most kids like this because you can't really clean it up much. So I have 4x squared times negative sine. That's going to be negative 4x squared, sine of x. Really nothing I could do there. Minus 8x times cosine of x. Cosine times 8x is 8x cosine. Pretty easy. All divided by, now, if you leave the denominator alone, I probably won't care, but it's a monomial, so you could square that pretty easily. 4 squared is 16. X squared squared is x to the 4th. Multiply 2 times 2 is 4. So there's a nice final answer. Now, I want to show you something else you can do. I like this final answer, and at this stage, you're probably good, but we can actually do a little bit more with this, right? We can make this even cleaner. So I've already found the derivative. I'm just cleaning it up. In the numerator, I could factor out a 4, and I could factor out an x, because both terms have at least a 4x inside of them. So when I do that, I get, let's see here. Actually, I can factor out a negative as well, because both terms have a negative. So I'm going to get an x times sine of x, because 4, factor out the 4 is just a 1. X squared, factor out the x is just x, plus 2 cosine of x. Again, if you don't believe me, just distribute to see that there's the negative 4x squared and there's the negative 8x. But factoring it out is going to make it look a little cleaner. Divided by 16x to the 4th. Now I can cancel, right? This 4 and this 16 can reduce to a 1/4. This x and this x to the 4th can reduce. The x in the numerator will cancel with one of the x in the denominator. So I get a final answer of negative x sine of x plus 2 cosine of x, all divided by, let's see, that 16 is going to reduce to a 4x cubed. Sorry, I'm scrambling that in there down there. So again, that would be just a cleaner final answer. So the thing here is, I'll be honest with you guys, all of this was all derivatives. Actually, really only this. This was finding the derivative. At this point, you have found the derivative. And then after that, it's all cleanup. And that's just algebra. Everything else I did after that initial step of using the formula is nothing more than algebra. And again, how many times have I told you guys since the first day of school that algebra is what's going to hold some of you back? The derivative rule is actually really easy. It's all that cleanup work that comes after that sometimes can be tricky for some students. All right, let's just do one more problem. The quotient rule is really easy. I don't want to bombard you with 18,000 problems. It's really just a simple rule. So once again, numerator, denominator, u, v, let's rock it. All right, so the derivative is going to be v, 1 minus x cubed. Don't change it, leave it alone, times the derivative of u, which is 8x. Again, 2 falls down in front, 4 times 2 is 8, x to the 1st. Minus, now this time I'm going to leave the top alone, 4x squared, times the derivative of the bottom. Well, the derivative of 1 is 0. And then the 3 falls down in front, which makes a negative 3x new power square. So where'd the 1 go? Well, the derivative of 1 is 0, so it's gone. And then the 3 falls down, negative 3x squared. All divided by the denominator, 1 minus x cubed squared. All right, again, now I'm done. Like, that is done. I have finished the derivative. Like, all of the calculus has been done. Now it's all about cleanup work. All right, so I'm going to get an 8x minus 8x to the 4th after I do the distribution here. 8x times 1 is 8x. 8x times negative x cubed is negative 8x to the 4th. Back here, I got to do some multiplication. Let's see here. These are two monomials. So if I multiply that, it's going to be 12x to the 4th negative. 4 times negative 3 is negative 12. X squared times x squared is x to the fourth. But I am subtracting that, right? There's another negative sign right here that's actually going to turn into a positive 12x to the fourth. So essentially I have a negative 4 times a negative 3, which is positive 12. X squared times x squared is x to the fourth. And then again, don't multiply, right? That's a binomial. It's an ugly binomial. 1 minus x cubed squared. I would just leave it like that. Like no reason for you to do more with that. You're just going to overcomplicate things. But I can combine my like terms. So in the numerator, 8x to the fourth plus 12x to the fourth is 4x to the fourth plus 8x, all divided by 1 minus x cubed squared. Now, you can factor out the numerator. You could factor out a 4x, but there's no point in doing that because it's not going to cancel with anything. Typically, we factor when we think, oh, it could cancel. For example, here, I saw that if I factored out that negative 4x, I could cancel with the denominator a little bit. But on this problem, if I factor out that 4x, it's just not going to do me any good. Now, listen, I would never mark you wrong if you factor out a 4x and you said 2x cubed plus 2. Again, check my work there. There's my, oh, whoa. Not a 2. What am I talking about? That 2 is gone. Sorry. Apologize. All right, there's my 4x to the fourth. If I distribute there, there's my 8x if I distribute to the back. And then again, over 1 minus x cubed squared. I would never take off if you did that, but it's just unnecessary because typically we factor when it's going to help us cancel and reduce. But again, factoring here is not going to help us. But again, I would never mark that wrong, and it's still full credit. So again, the first step, right, the quotient rule itself is the calculus. And I think that rule is actually pretty easy. Everything after that is really just cleaning things up, which sometimes can be a little bit tricky, so just be careful. I hope you have good algebra skills. All right, guys, that's it for the quotient rule. It's actually quite simple. Get ready to use it on a couple examples. The hardest part is cleaning it up with algebra.